Hello and welcome to our latest podcast. This episode is given by our President Graeme Fox, where he talks about heat pumps and the net zero agenda. It's based on a presentation he did for members towards the end of 2022 and covers the main conclusions and the discussion. The podcast is chaired by Dermot Cotter, chair of our Papers Committee. In this podcast, Graeme highlights the need for greater integration, not just of heating and cooling systems, but also greater joined-up thinking at engineering, design and political level. You can download the full paper or view the webinar from the Institute website at ior.org.uk. Over to Graeme.
There are enormous opportunities available to us as design and build engineers to shape the net zero agenda using our sector technology without even really having to think too far outside the box or adapting equipment to suit a particular installation. Standard kit is available to us, which can impact enormously on the decarbonisation of heating drive, which government is now taking on. We simply need to apply our knowledge in the most efficient manner. Heat pump technology is not new, but it is evolving hugely, becoming ever more efficient and reliable, but it has to be applied correctly. It has to be designed, installed, set up and handed over and maintained to ensure the possible efficiencies are realised and sustained. We've all read the horror stories in the mainstream press about how awful heat pumps are, about the astronomical energy bills that consumers have faced. In the past 6 months, I've been interviewed by the Financial Times, The Guardian and The Times, all of whom wanted to discuss heat pumps, and all of whom were given examples, real examples, of where heat pumps have been proven to be absolutely the best option to the homeowner. Not one of those mainstream newspapers published anything that I told them, not one of them, despite me explaining to them that the systems only perform badly when they've been badly designed or set up. This is an enormous obstacle that we as a sector need to clear if we are to get public buy-in for the heat pump technology. It doesn't matter how many government schemes offer grants or subsidies. So how do we overcome this? Better education of end users is critical. And more importantly, better education of our own sector designers and installers. Around a year ago now, the BESA and the Heat Pump Association were discussing this issue, and we were looking at creating an upskilling course to ensure that heating installers could get an understanding of what our technology actually is and how it worked. How it needs to be running if it's an air-to-water system at a lower flow temperature to actually realise the energy benefits, and what that means in terms of design, setup and handover. After all, there's no point in setting up a system perfectly if the homeowner doesn't then understand that running a system at a lower temperature but for a longer period is actually cheaper and more efficient. So it's a bit of a mindset change thing that we're facing here to try and get that message across, and that's not easy. Eventually we developed our own upskilling courses. The BESA started delivering a heat pump awareness course for heating engineers in February this year, and we've upskilled around 1,500 to 2,000 engineers, I think, to date. And we've actually just secured funding from BEIS last week to deliver another 400 or 500 fully funded upskilling courses for heating engineers to actually get their heads around how this technology works. And the Heat Pump Association started delivering their course through manufacturers at their training centres, I think around midsummer this year. So we are getting there. The better informed the installer is, the better the system will be set up, and the more able they'll be to explain to the homeowner how to run their new heat pump systems in the most efficient way. I find myself in meetings with ministers and their advisors frequently where they talk about heat pumps, either for or against, but I find generally they're only talking about one type of heat pump, air-to-water monoblock systems. Now, they're not the most efficient, nor even the best type for many buildings, and especially for retrofitting into existing homes usually. Retrofitting is a massive problem. We have net zero targets for 2050. Most of the buildings we will be using in 2050 have already been built. Some of them have been built some time ago. 90%, we reckon, of the buildings we'll be using in 2050 have already been built. So building regulations changing the way new buildings are built isn't actually going to address this issue without looking at the retrofit market. It's really, really key. This is the reason why I produced the non-technical guide to heat pumps to use when we were lobbying and to disseminate to government departments and the quangos. It was very, very basic. It was a kind of, this is an air-to-air system, this is an air-to-water system, which we've now just recently tweaked and published through the Beyond Refrigeration Environmental Group, the IOR. Again, getting that messaging across, letting people understand what heat pumps actually are, and that they're not all air-to-water monoblock systems. Now, this is really important because we are led by decision makers who don't even have the most basic understanding of what options are available to them. And my role at the BESA Group now is to try and make sure that the decision makers, the policy makers, actually have the right information to hand, so that they will hopefully make better and more informed decisions going forward, which will only serve our sector better in the long run, of course. But even when we look at ground source systems, there's a variety of sources and delivery methods. One which offers significant benefits is the multitude of aquifers which exist across the UK. Now, these can be used as low-grade heat source for heat pumps to boost locally to useful temperatures, often relatively cheaply, as long as the local authority approves their use, of course. And river water exists across the country which can be used. The Queen's Quay project in the River Clyde in Glasgow is a perfect example of using an existing constant source to deliver low carbon heating for a huge number of properties, potentially, both domestic and commercial. But one I touched upon in the paper where I had some experience myself is in flooded, disused coal mines, with water drawn up as low-grade heat in the region of 12 to 20 degrees, boosted by a heat pump with only minimal heat drawn, so that the return water is around about 7 to 15 degrees. And a heat pump, or localised heat pumps, used then to provide useful space and water heating in properties. There are dozens of disused mines which could be used like this, providing low-carbon heating for social housing, or just decarbonised heating for heat networks and district heating networks, for example. Which brings me to the bigger picture aspect of what I was trying to convey in my paper. Not just using available source, but also recovering heat where we are currently rejecting it. We have approximately 41 million cubic metres of cold storage space in the UK, according to the 2022 Cold Chain Report. Now, that equates to around 2 million kilowatt hours of heat rejection, much of which is currently thrown away to atmosphere. In simple terms, that equates to around 200,000 homes worth of heating. How much social housing could be delivered with virtually free heating if we were to harness this rejected heat energy and convert it via localised heat pumps into district heat networks? So at a time when we're facing rapidly rising energy costs and a sharp cost of living increase, why aren't we looking to recover more of that waste heat and delivering it to those most in need? And when we look at supermarkets, and I do say this knowing that a number of our leading supermarkets are indeed looking at this, but we have the ability relatively easily to recover the waste heat from our fridges and freezers on the shop floor, as well as back of house storage, with just a little bit of joined up thinking at the design stage. But it's all about that joined up thinking and the collaboration across the sectors. In conclusion, our sector, representing industrial and commercial refrigeration, as well as building services, air conditioning and heat pump applications, needs to approach projects with a far more collaborative attitude going forward. Megawatts of usable heat is being rejected from cooling applications every year, and much of this could, with a little bit of joined up thinking, be recovered and used to supply heat for the social housing or heat networks. The building services design consultants need to work more collaboratively with the refrigeration consultants so that we can harness that rejected heat and help our built environment become truly carbon neutral. Integrating the design of building services, heating and hot water systems with one eye on the nation's cooling load across so many of the building types, and building into that equation an increased use of the renewable energy supplies and the greening of the electrical grid itself offers opportunities for rapidly reducing our carbon consumption for our building energy needs. At the end of the day, every butcher shop, bakery, funeral parlour, corner shop, fast food outlet, they all have a mixed requirement for space and or water heating, coupled with some specific cooling load. So it is essential that those involved at the design stage of building one of those properties, or even looking at an overhaul of the system installed at the end of asset life, do so with an open mind and incorporate the recovery of the heat rejected from that plant, the cooling plant, to supplement the heating demands at the very least. The possibilities have enormous implications for the RACHP sector in terms of increased workload. But this in turn will demand more skilled technicians on our sector. The training requirements for a host of technicians entering the sector or needing upskilling cannot be met by the current way we deliver training. A shortage of trainers and assessors, which is not likely to be addressed in the short term, means we need to look more holistically at how we deliver upskilling training for both the air conditioning and the heat pump engineers and heating engineers through hybrid courses, with more training delivered as short courses. It's something we are currently looking into at the IOR through our ACRIB engagement. So the opportunities also present several challenges for the sector going forward, but with a more open mind to the commercial opportunities and a more collaborative approach, and even within our own RACHP sector going forward, the future for the sector and indeed our institute is very bright. Thank you.
Well, I would like to thank you for your talk tonight and your opinions and how to change. And the big challenge is how, as the president, you can influence change, but how everybody else around you can help as well. So thank you very much for tonight.
Thank you.
And do we have an issue in the industry that, whilst people know about this technology, they have ideas about it, but should it be a qualification to actually be installing a heat pump into a house? Anybody can just put in a heat pump, and therefore that's when it goes wrong and a bad reputation. What do you think what should be done, and who should actually make a change?
Well, we've been looking at qualifications for that subsector for the last 18 months. I've been working with the Department of Levelling Up Health and Communities, trying to update the minimum technical competency standards that were developed. They were in the National Occupational Standards 15 years ago. When we sat down to look at how we could update them, it took a long time, say 18 months. And it's only now that they're just getting signed off by the working groups to go out for consultation. What we actually found was a lot of the qualifications are there. It's just a lack of application knowledge is the problem. The qualifications haven't really actually changed that much. The qualification needs haven't changed that much. If you're talking about air to water systems, obviously the water side, it's plumbing and heating engineer qualifications. They haven't changed at all. On the refrigerant side, it's refrigeration air conditioning qualifications. It's not so much a qualification that's needed. It's a knowledge thing that's needed, and that's why we in the Heat Pump Association created the upskilling, the heat pump awareness courses that we run.
Neil Merritt is asking, with regards to overhauling training and thinking more holistically, what have you seen as barriers to collaboration with heating and building engineering experts in the area?
I think the biggest barrier has been where people are trying to apply government grants and things like that. A lot of them are looking for things like that, and you need to have the MCS accreditation, and that tends to fall into the heating engineers, traditional heating engineers as the installers. But as we've seen, so many of them actually don't understand what it is they're doing. They don't understand what a heat pump is. They don't understand how to properly set up a heat pump. So that's probably the biggest barrier in terms of that. One of the, as I mentioned, we've just been given some more base funding to upskill another 400 or 500 engineers, and actually we're doing that in conjunction with MCS this time. So the qualification that comes from that short course will actually be MCS approved, which will be a big help, I think, going forward.
And should it be only those people then with that kind of qualification be the only ones allowed to install them? Because you need to kind of, years ago, you had the people doing wall insulation, and you get people just going into it and just learning how to foam it, and that was a disaster. Then you have people doing solar panels, and there was challenges with that.
Yeah.
Would you actually, if you had a son or a daughter and they had an old house, would you just let them go down the road and knock on somebody's door and say, "Can you give me a heat pump, please?" Would you be confident with that you get the right solution?
So that's where the upskilling training comes in, because one of the main features of that upskilling course is actually about understanding the different types of system and the applications. The limitations of some systems is really, really important. So as I said, retrofitting is going to be a massive part of the equation. But actually retrofitting into old properties, air to water heat pumps are often the worst possible thing you could be doing, because you need to be delivering a water heating system at low temperature to really realize the energy efficiencies. But in an old building, if you're trying to run that at 40 degrees instead of the kind of traditional 70 degrees or something, then you're either having to massively upsize the radiators, or you can stripping out radiators and putting in fan assisted ones. The actual distribution pipework itself in most old properties is microbore. You can't do low flow temperature heat pump systems with microbore. So the entire piping system has to come out anyway. And often when you look at a system like that in an older property, you're actually far better putting in air-to-air systems. because you don't have all those obstacles to overcome. You free up walls that have currently got radiators on them. It's not a problem for people. And also you get the instant heat that you don't get from a low temp. One of the big problems that householders find with an air to water heat pump system is that if they go on holiday for 2 weeks and they switch your heating off to save energy, but you can't then just switch that on when you come back. So it'll take another day and a half to actually get the house back up to temperature. I read there was the BBC journalist. He has a holiday home in Wales where he was complaining about heat pumps. They're absolutely useless, he said, because he tried to do the right thing by putting a heat pump in. But he says if he goes for a long weekend in Wales and he switches it on, by the time it heats up, he's coming home again. I thought, well, that's not a problem of the heat pump. That's a problem of whoever designed that system for him. And what they should have, what the installer should have said to him when he asked for an eco-friendly heating system, he should have had an air-to-air system. It would have been pretty much instant heat. You're not having to get the heat back in the fabric of the building before you feel the benefit of it. That's the beauty of it. You're actually getting that comfort factor pretty much instantaneously. So that's the sort of advice that needs to be better communicated, I think.
Paul Singh has written in, and he's asking which skills, knowledge, behaviours are required to tackle net zero.
Behavioural, I mean, it's an education thing. So the installer needs to really understand what it is they're designing and installing. They need to really understand it because they need to explain to the householder about that requirement for running at low temperature. As I said, it's the household is used to having nice toasty radiators. I mean, we had a similar thing, the Castle Course clubhouse when we first switched it on, and we had all the data loggers in. We could prove the temperature was stable throughout, but the actual building, the building manager, property manager on the St Andrews Links Trust, he phoned me up. He said, this system isn't working properly, Graeme. You need to come and have a look at it. So, okay, I logged in remotely. I could see it was perfect temperature throughout the whole building. So, jumped in the car, drove over to St Andrews, and I met him on site, and I said, what's the problem? And he put his hand on the floor, and he said, we've got underfloor heating, but it's not warm. And that's the sort of thing, it's not meant to be warm. You're not going to feel it warm in 40 degrees in embedded concrete. But what it's doing is it's providing that heat into the building over a long period of time, very low energy. And how do you deal with that kind of mindset? And it's really difficult. And I think this is one of the big problems that we've got. So behavioural change is an education thing. The actual installers need to really understand that technology so they can properly explain to the clients how to run their systems at the most energy efficient way. That's probably the biggest challenge.
Thank you, Graeme. Steve Gill with a question. Thank you. And lots of questions actually, but I'll try and keep it short. Obviously, the building stock, although it's 90% is going to be older than it is now, so we're involved in construction and construction of the new 10%, builders or retrofitting, upgrading of the building fabric. We've got additional need for cooling. We've got additional decarbonisation of heating, and the crossover between heat pumps and the cooling sector. This all traditionally has been done in silos. How are we going to unite or connect those silos and stop it creating all the problems that come from all the things you've explained?
Yeah, it's a lot of government policymakers, and they've not wanted to be seen to be encouraging the use of air conditioning. But as you say, climate change, we have a warming planet, the actual and the equipment that we have in our homes and our offices and things nowadays is putting that necessary cooling load on buildings now. So with that, that's kind of why I lobbied HMRC about heat pumps, because they moved the goalposts on the reduced VAT rate, as it was at the time, the 5% VAT rate. And air conditioning systems were explicitly written out in October 2019. And that was kind of where I came up with the idea of the idiot's guide to the heat pumps, because when I finally got the right guy at Treasury, who's the head of the department to call the reduced VAT department, he said, oh yeah, Graeme, but air conditioning units, when they're used as heat pumps, they have an electric heater battery to boost the air off temperature. I said, Patrick, we haven't used them in 20 years. Got that message across, and it actually happened very rapidly after that, which they accepted. And then, as it happens, the Chancellor then, instead of adding in the air conditioning heat pump units as the 5% VAT, reduced VAT, they actually decided to zero rate all of the decarbonised heating for 5 years. So that was a big hurdle that we got through, and I think getting that mindset into government departments that we've now got, that there is a need for some cooling, and actually if you do need to use it for cooling a week or two of the year, it's not a bad thing. When the other 50 weeks of the year, you've got the most energy efficient heating system for those buildings that need it. And as I say, it's a lot easier and a lot cheaper to install air-to-air heat pump systems in a lot of these old properties, particularly housing, than it is to strip out what you would need to do to put an air-to-water system in. I hope that answers your question.
A couple of questions, one of them on a practical level. You mentioned about heating homes using a heat pump at lower temperatures. What about the hot water for washing and things like that? How do we deal with that? Do you see that still being different type of technology in parallel if we're going for an air-to-air system? My second question, which is totally unrelated, but as an industry, particularly in terms of manufacturers and development, what do you think are the real key things that we need to be focusing on in terms of the product?
That's a much more difficult question. I'm going to deal with the first bit first because that's a lot easier. How do we deal with the domestic hot water side of it? The electrical grid is obviously greening more and more all the time, so actually using electric resistance heating for the domestic hot water isn't a bad thing. You can top that up with obviously with a solar thermal system, so you can use solar batteries to actually create that hot water and then just use electric resistance heating to boost it, or where you haven't got the sufficient solar. That's probably the easiest way of doing it. Some of them, the new generation of heat network equipment is actually able to deliver that water at more like 70 degrees without the huge energy penalty, because they're using low-grade heat from, for example, flooded coal mines or from aquifers. So because you're actually raising the temperature from a relatively stable and slightly higher temperature, I think the heat pumps and the new generation of the booster heat pumps that are being made available in the market are able to raise that to kind of 60 degrees plus a lot more easily. So that's one way.
What think of the heat pumps that you can get in a hot water cylinder that you air in and around ducts? Do you think they're good for a domestic house or agent?
The ones I've come across were pretty awful in the way they actually performed, to be honest with you. But again, it may have been poor design that I was asked to come and look at.
Early technology.
And they were very early technology, yeah. There was some of them are designed for where you have more like a passive house kind of setup. So you've got really, really good air tightness of a building, which can really help with the way that the heat's delivered into a building. But as we've all seen, and you'll know, one of my big kind of things is about indoor air quality, and the pandemic has really highlighted the need for good indoor air quality, need for air changes. So actually, I'm really not in favour of that kind of air tightness of a building, because buildings need to breathe. People need to have that change of air. There's been a massive rise in the number of asthma cases in the country in recent years, and that's because the government's been giving people grants to throw this extra insulation into the homes, and you're cutting off the homes from actually breathing. That's why we have mold issues in homes, because we're over insulating buildings and they're not breathing anymore. I think back to my grandparents' generation and before, they all open coal fires, and yeah, it was drafty. But actually, that draft was actually creating a healthier environment. Even though they had log burning and coal burning, it was actually a healthier indoor environment because you had that airflow going across the rooms. So that's kind of where I'm coming from. That second part of your question, I haven't managed to avoid, have I? Sorry, remind me.
So it's really where does the technology need to go? What do
the manufacturers?
What have we got to focus on now moving forward?
Key things for manufacturers. I think if you're talking about for domestic heating, I think the controls is key. Controls has to be really easy, because to have idiot-proof controls, it needs to be as simple as possible, but actually still maintain the operational performance. So that's probably the biggest challenge, I think, for manufacturers of heat pump systems from a domestic point of view. Thank you. Thank you, Rob.
We have another question from the audience. Can he come up and introduce himself?
Andrew Geagle. A few years ago, Chris Jessup and myself had a look at the heat pumps from a different perspective. Why didn't people want the damn things? And all my experience has been heat pumps that don't work, all the people want is to get rid of them and have a gas fire. You know, it works.
Yeah.
And they want the same sort of technology. But one of the things we did consider, which I don't think you've really addressed so far today, is you actually need some sort of energy storage, either on site or very, very close to the site, so that you can disconnect the demand for heat for demand on the grid.
Yeah.
Have you given that some thought?
Yeah, I didn't actually discuss it this evening, but I did mention the paper about that need for some kind of sort. I think I did anyway. Need for some kind of energy storage, because you have to have that balanced load, because the cooling the heat being rejected by the cooling plant is not necessarily going to be rejecting that at the time you need the heating in the buildings. So and that's, yeah, I was paying attention to your paper. I was at your paper a few years ago. I was paying attention. No, it's a really important point, that battery storage. And again, you know, when you did your paper, even the technology for that has moved on quite significantly in the last few years. So again, as they become more efficient, the actual storage itself becomes more efficient, then it's a big part of the need, because as you say, you're not necessarily generating that heat at the time when you need to deliver the heat, so you have to have some method of storing it.
Mike Creamer, in my home, I've introduced several years ago solar tubes, 12 tubes that produce water at about 75 degrees C when the sun is up in the south, which is just fantastic. But as Andrew's just said, the real issue is that when it comes to night time, the sun's gone down and I have no storage. So I'm thinking about the storage element. But years ago, there was an American manufacturer who came up with a solar-assisted heat pump technology. And where we're seeing some of the air-to-water heat pumps being so efficient now, some getting up to a COP of nearly 4 when it's at nearly 0 degrees outside, that's pretty good. But we also know the water-to-water heat pumps are also very good. So I'm sort of starting to imagine tonight, from the great talk you've given, is there some great way of actually combining solar tubes to put a lot of heat energy into your water storage, and then when that starts to fall off because the sun's starting to diminish in the autumn and the winter and so on, that you still get energy from it, but a diminished amount at lower temperature, and then you use a water-to-water heat pump to lift that to higher temperatures, so you don't have to change all your radiators in the house and so on. Maybe combine it with air-to-water as well. So just a thought.
Yeah, I mean, this is the thing I was saying. There's loads of options available to us as design engineers, and you have to choose the right option for the right application. One thing we haven't talked about, and actually I think solar PV is possibly more efficient than that in terms of generating the electricity power from it. And you either have a battery to store that electrical power until it's needed, or another technology that I haven't even talked about at all is phase change. Hot water production. I went to, there's a factory just outside Edinburgh, but it's quite new, and they have these boxes. They're essentially about a metre high, I don't know, 600 mil square, and they're just plumbed through, almost like a hot water cylinder. But all it is a heat exchanger with this phase change material in it, and they actually showed one of these things that is generated when it comes off the production line. And I watched them taking this thing off production line, plumb it in to their rig that they had in the factory. And it was instant hot water at 50 degrees, instant. That's massive, what you're talking about for that kind of domestic hot water use. And I think there's a big, big future in that avenue. And either using the solar PV to power it to charge the system up, or obviously, as I say, the electrical grid itself is becoming decarbonised more and more on a daily basis. So yeah, but we do need to, the government does need to address the subsidies of the actual fuel supplies, definitely.
On solar PV, I got excited about that. I've just got the quote. For 4.2 kilowatts into the house, 11 panels, £8,000. So, okay, let's think about that. Will I live long enough for the payback? But then at night time, the sun's gone down and I don't have the power. So let's go for the battery option. Tesla battery, £11,000. So I've got my solar panel and battery get installed next week. So.
Okay.
We have a final question. When I asked for one more question, I happen to get two hands, so can you come up and introduce yourself?
I'm Martin Craxton, and I'd like to take up the question about balancing between heating and cooling. We've had presentations in the IOR about, for instance, that Glasgow Riverside project, and we've heard on radio recently about heat from the street projects. And I just read in the CIBSE journal, the latest one, about the Bankside Yard, where there's a massive, great development where it's residential and offices and a mixed development, and it's actually going to be working on an ambient loop at around about 20 degrees. My question is, what sort of encouragement is there from the government for these sorts of distribution networks, which are obviously going to be the solution for water to water and balancing loads in an urban environment?
Encouragement from government, I'm not sure, probably grants and subsidies in some way, but one of the big problems that I know heat networks have had has been poor performance, again, over the years. One of the reasons why we created HIU standard within BESA about 8 years ago now was actually to address this. So we created a standard for the manufacturers to actually achieve. Most of the heat interface unit manufacturers send their units to one of the 3 independent test houses who test to our standard, and at least that way they are stamped as being of a suitable tested standard. So that's one way of addressing it. We are currently in the process of upgrading that standard for the keep warm rates and all this kind of stuff, and maintaining return rates, currently going through the technical committee. And then we need to get the test houses to update their test rigs so they can meet that new standard. But because we're doing that, the work we're doing with that, so BRE operate the SAP calculation database, the product characteristic database on behalf of BEIS. They have now given us access to directly apply our equipment that's been through the BESA test. The test houses send the test results back to us, and my team can actually update that stuff directly onto that product characteristic database, which you've never been able to do before. One of the concerns people had was that the architects, designers were having to use software that was so out of date, the database was so out of date that they have new technology, but because it wasn't on this database, it was actually getting really bad energy penalties for designers. So they weren't designing the best equipment for a job because they couldn't actually meet the building design requirements. Or the building control requirements at the time. So that's something that they're doing. The other thing government is doing is we talked to BEIS about a year and a half ago about the heat network assurance scheme. We wanted to have a kind of guarantee scheme that if someone was signed up to this scheme and you can actually demonstrate that the heat networks that you're creating actually work to a suitable standard, it gives homeowners that peace of mind that actually the heat getting delivered on the heat network is at the right level, which then means that the heat interface units that are installed, that have been through the test standard and are approved, it guarantees to the homeowner you're actually going to get that delivery. Because again, that's one of the big problems that people have had, that heat networks to date have often not performed as they were expected or supposed to perform. So the end user loses faith in the system itself. So that is now progressing. We've just started that about 2 months ago, I think. We've got a working group within BEIS that I sit on, that we're creating this heat network assurance scheme. So that's the kind of limit I think the government evolved in. So they're not actually having to spend money, but they're helping us to create this heat network assurance scheme.
Thank you very much.
So this was the tip of the iceberg from the Institute of Refrigeration. We hope you're enjoying our podcasts. Please like and share and follow the podcast and join us on the next edition.